Hello, everyone. I'm Nicole Echeverria, the Digital Marketing Manager here at L&D Technical Service, and I'm so excited to have Alex Echeverria, our VP of Engineering, here in the studio today. How are you doing?
Very good. Thank you, Nicole.
Thank you.
Glad to be here.
Yeah, and Alex has over 35 years of engineering experience, so one of the most experienced leaders on our team. So excited to ask you a lot of questions about leadership in the engineering industry, how you've seen it evolve over time, and your expertise and how you're bringing that to L&D and to growing us into the future. The first question we'll get into is I know in your decades of career experience, you've grown an engineering team and you've picked out like traits that you've seen in maybe junior level engineers and workers to bring onto your team. What would you say are the traits that you look out for when you're either hiring or you're bringing someone onto your team that makes someone a person that thrives in the engineering industry?
Yeah, well, that's a good question. What I'm specifically looking for in experienced people is that they understand generally the whole power system that we're analyzing and we're what we're expected to know. We're in the protection control field. We need to know a little bit, well, not a little bit. We need to know in good detail about the whole power system. So we're not looking for specialists in transformers or breakers or transmission lines and generators. Those are specific specialists that they study that their whole career and they're good in what they do. What we're looking for is somebody well-rounded in everything. So that's hard to find. It takes, somebody who's been in the field for a good amount of years. So when I interview somebody, I that's what I'm checking for. How well-rounded they are, how they understand the different components of the power system. And I just really looking for a breadth of knowledge in all those areas. And basically when I interview somebody is I kind of ask them to connect the dots for me. So I have from my experience, I have a good long term vision of what I have a good long term experience of what I've done, so I know how to connect the dots. So I'm looking for somebody to connect the dots during an interview process. So we're looking for a well-rounded individual and during the interview process, since we're kind of a top-heavy company, a lot of our people are senior people, so they need to understand and perform as a senior engineer. So when I interview somebody, I ask them to connect the dots for me. So I talk about specific examples of different protection systems, leave a few areas out, and see how they connect the dots during the process. And I found that to be extremely successful. I have been in this industry for 35 years. I have a pretty, and then being in a senior position in hiring for the last, I think 15 years, right? Just about been very successful in making excellent hires. And I think one of the reasons for that success is that I end up have a good understanding of what needs to be done. And I understand that when I'm interviewing somebody, I want to see that reflected in the person I'm interviewing with. And so far, so good. And, so that's one thing, when hiring, senior level people. But when hiring young people, to be honest, I just like to get my hands on these individuals right from the beginning. So I've had a terrific track record as well with getting former interns. I think I literally hired over the course of my career 7 former interns I had who were interning during college. So that's a great opportunity for me to kind of see how they approach work, see their curiosity, see how they're willing to ask questions, because there's so much to learn in this field that you need to ask questions. And if you're not asking questions, you're not going to have a good career in this area. Again, the funny part is like over my career, I think my first intern, couple of interns, I think actually my first intern was from like around 20 years ago. And now he's now my principal engineer at LND. On focus on automation systems. He's one of the leaders in that area. So I've had a great record with that. And, so I'm really proud of the hires I've had. I can't remember anybody, which is kind of odd when I talk to my counterparts, everybody has some horror stories and poor hire. So I really haven't had that, and I think it's because of the level of expectations I have. And I make that known right from the beginning with my interns. And I make that known, of course, when I'm interviewing somebody. who's in a senior position.
That makes a lot of sense. And I know at LND we work on a lot of renewable energy projects and really large scale, like power infrastructure types of projects all over the country. As a leader, how do you ensure like seamless collaboration between the different people and different departments that are all working on one project simultaneously?
Or renewable projects you're talking about, right? Yeah, so renewable projects, it's a growing industry. It's something that we're talking about in conferences now. There's a lot of different components to it that are not a part of our traditional, what we normally do think about when setting these relay devices to protect these inverter-based resources. So what we're doing now is we're trying to get as much data as we can from the renewable company on the solar specs, on the if it's a wind farm, as much information on the wind farm specs. If it's a battery, as much information on the battery, just to better protect their valuable equipment. So remember, what we do in protection control is really we're there to protect their equipment. I know that a lot of these renewable developers, they have their own specialists and they're there to protect. But as we've seen in the industry, we can't have the developers just protect their own equipment with disregard to the power system. We already have several examples where that led to cascading faults. So now with NERC, they're putting some industry standards specifically geared to the renewable developers and their equipment, because they can't just go offline to protect their equipment with disregard to the power system. So it's a lot of collaboration with the developers, getting good data, running the studies that we need to do in order to understand how the impact of that renewable inverter-based resource impacts the power system. Basically, what it comes down to is the more data we have, the better we can protect not just the renewable equipment, but protect the substation, the transmission lines, the transformers, and everything else.
Amazing. Thank you. And I know compliance is a big, important issue in the utility industry. How at LND have you prioritized the importance of safety when it comes to our team members, the equipment, everything? I know at LND we have a monthly safety meeting, but how have you prioritized the importance of safety in the work culture?
Well, the safety is always the most important thing. We want our staff, whenever they go into a substation or a power plant, to understand the dangers and the inherent dangers of going into those facilities. So we have a good safety culture. Part of our team, half of our team, I'm in charge of engineering, but the other half is field service. But the engineers support the field service, so they're in the same places as our field service people are. So even though they're in the side of engineering, wearing the college shirts and stuff, they need to, put the safety gear when they're gonna, the safe clothing and the hard hats and the goggles and everything you need to do, the safety shoes and all that when they go into a facility. So even though we're not there every day like our field service people are, we do go there. So they need to be involved in all the safety training. They need to be up to speed in arc flash protection, and they need to participate in the monthly safety meetings, because the valuable lessons learned are discussed during those monthly meetings. So I'm very proud of the safety culture we have at LND, and we just got to keep up the good work and make sure that we have good participation, because if you slack off, and again, unfortunately, a lot of times when you have people with a lot of experience, they think they've seen that, done that, and heard that, and the reality is, unfortunately, sometimes the people who are the most experienced end up getting the serious accidents because they take things for granted, because they've done it forever. So we don't want that. So we have a good safety culture, monthly safety meeting for all of our staff to attend. Knock on wood, we'll keep on doing well going forward with that.
Yeah, amazing. And I know you mentioned before your track record with bringing on interns and bringing them into your engineering team. Is there any like particular strategy that you've seen be very effective in mentoring junior engineers in your career?
Yeah, I mean, again, I think I've done that. So what we normally would do, what I've done in the past, and now I'm gonna have our senior engineers do that with the junior engineers that are in L&D and the ones that are coming, is to establish an expectation level. I think that's what's missing a lot. It's you gotta establish what we expect of people. And for junior engineers, for interns coming in, they gotta understand the breadth of what they need to learn and the responsibility that comes with it. Again, it's when you're in a company, like I was in a utility for over 32 years, and what I used to tell our team all the time was that, if there's a fault in the system, a cascading event, whatever may have happened that blackouts a particular area, there may be in the utility, there may be some civil engineers, there may be other electrical engineers that spec out equipment, there may be mechanical, etc. But the only people who will be targeted for blame if something goes wrong is the protection control engineering group. Right. So we have to be mindful of that we have a greater responsibility than other people do. So, and that's what I try to teach our interns right from the beginning, that we have the bullseye on us. Obviously, nobody's perfect, but we need to do our due diligence always. And we have to be on top of our game always, because if an event, a blackout, whatever the case may be, we'll get the blame. So that comes with the job in the utility. We get the blame no matter what. So we can't be perfect, but we need to be not close to perfect, but we just to me, I like to say we like to do our due diligence. Make sure that every contingency that should be accounted for gets accounted for. And when we finish our project, we feel comfortable that we took all contingencies into account in our calculations and our settings, and we feel good about what we did. And that's something, that expectation level needs to be brought kind of disseminated to the interns right from the beginning, so they know what they're getting into. Because I don't want somebody who doesn't realize the expected responsibility that we have. They need to know that right from the beginning, so that they have that culture of making sure that they did the due diligence in their work. It gets part of their foundation right from the beginning. So that's what I do right from the start. And again, I've been very successful with that.
And I know at L&D we always hold people to high standards, so it's important to maintain that level of excellence, which I think we're all really proud of. And I know new technology is introduced into engineering and the energy industry all the time. Have you learned any particular lesson about growing a team when an industry is changing so fast? Or do you prefer to grow teams very slowly over time? Or like, what's your strategy?
Yeah, that is a very good question. We're kind of these last 5 years or so, we're really at an inflection point now where there may be areas of pretty drastic change in our industry in how we automate these substations. It's not taking a strong foothold yet, but it's happening. And so as we start going into this digitation age from where we were before, and again, other than the actual devices that might have gotten a little fancier, and from electromechanical days, when you had 10 devices, now you can put those 10 devices into one box. You still need to bring the hardwire CTs and PTs into these relays. Now these relays are still digital, but now instead of bringing these hardwires and CTs, PTs, now you just bring fiber to it and send a message from the CTs and PTs to the devices. So that's something that's starting to change the industry. It hasn't taken a strong foothold yet, but you can see the change coming. You can see the discussion topics at the relay conferences that I attend. This is now going to start changing not just the learnings of the engineer. Now they need to kind of keep the fundamentals of power systems, but also now get a better understanding of the communication component too. So it's not getting easier. In short, it's going to only get harder for the engineer to do his job. There's more to learn. I think a strategy of thinking that keep the protection control engineer just isolated to the device is the wrong approach. We need to, as a protection engineer, we need to know everything. Like I mentioned from the beginning, we need to know a little bit about everything. So now throwing communication into that mix, the type of communication where messages are sent back and forth and through these Ethernet switches. So it's just another learning we need to do. So my approach right now is really just to suck it up, and we got more to learn. That's all. And that comes with responsibility. I don't think the right approach is to develop a different group just in charge for the communication part of the relay communication. I think we need to be developing well-rounded engineers in protection control so they understand everything, including the substation automation. That needs to be part of the learning. You can have a separate group, maybe more concentrated in that, but still the fundamentals need to be part of the of the understanding that these engineers have.
Great. And then I know with each new project, no matter how different, you're making a variety of complex decisions, whether you're making sure that each thing is being optimized, great performance, sustainable. If someone was just promoted into, let's say, their first engineering leadership role, like they're a new director, is there any piece of advice you would give a new engineering leader to make faster decisions or how you make fast decisions?
Well, yeah, I mean, if somebody gets promoted at a senior position, director level, manager level, the major responsibility for that individual is to make decisions. We need to do that, and the only way to make sure you're comfortable in your decision is if you develop the foundation over several years of experience. Protection control engineering is not an area where you can use a term "fake it till you make it." Okay, there's no such thing there. If you do that, you're gonna not last long, and you'll be out real quick. You need to have that foundational understanding in order for you to make those decisions. That's going to be really, really important. So if you have a track record in PNC that you were working as an engineer for 5 years and now you're a manager or director, I like to kind of meet that person just to see maybe they're just a genius who started doing this right at college, and instead of really 5 years, they really were doing this for nine. Okay, I could believe that, but 3 to 5 years of experience does not get you to a manager or director level. And if it does, you really don't have that foundational knowledge that's needed to make good decisions. Again, we have a target in PNC in that we need to be as close to perfect as possible, because any mistakes that we do can lead to outages. That's not something. That's something nobody wants. That literally can cost billions of dollars if you have a long-term outage. The blackout of 2003, the whole Northeast got blacked out. So it wasn't really because of a major error in a setting, but there was some loadability issues there that now the industry took that into account, and now there's some regulations, some standards developed to not have that happen again due to increased load. So now we have a loadability standard, PRC 23. So there's things that we need to understand, and somebody in the leadership position, they really shouldn't take that job unless they have good foundational knowledge, because the ramifications could be very catastrophic. So I hope people understand that. Make sure before you take that position that you're ready to make those critical decisions.
Amazing. And then from a systems engineering perspective, this is a little bit more niche, but in terms of microgrids, how I know it's like a hot topic, how have microgrids reshaped the way you think about distributed systems in the clean energy industry?
Yeah, so microgrids is something that's a nice new area for supporting the power grid. Right now, I think it's a not just a niche, but it's a good alternative for let's say displaced communities, areas where they just may be one distribution feed to a community. So having a microgrid there supporting that, I think is a great alternative. Microgrids in general for a typical area in the utility, I don't really right now see the need or the purpose of that, unless it's an area that's prone to hurricanes and everything, and they feel that they develop a microgrid that can be hurricane proof or something. I mean, I really don't know, but for me, the idea of having microgrids for an area that's underserved, rural communities, any area where, let's say, power needs to be critical, and to develop the redundancy for the systems to power, let's say, a major hospital. They can have their own backup microgrid, provide us power to sustain in case there's certain outages. But for me, it's really, I feel that the good value of microgrids is really to provide underserved communities alternative power, because usually those are the communities that get kind of the last look. It is what it is. Unfortunately, they just get one feed. And there's a lot of underserved communities in Puerto Rico where microgrids will be a perfect solution for them. So I think, for those types of communities, I think microgrids is a great solution for that.
And that relates to the topic of environmental justice that you've mentioned before. That's an upcoming topic in the industry. It's related to that underserved communities and being a viable renewable energy option, right?
Exactly. Yeah. I mean, again, depending where you are, I mean, I'm sure there's areas in rural U.S., in different states where that could be a great solution, having a develop microgrid systems to that. To those underserved communities, I have a lot of experience in Puerto Rico, working there from right after Hurricane Maria, and I'm still there supporting them on different projects. And there's a lot of underserved communities there that a microgrid solution would be ideal for them. So yeah, I mean that to me, I understand the greater use of microgrids for where redundancy may be too expensive for the regular distribution to feed hospitals, police stations, etc. Critical infrastructure. Maybe the microgrid could be developed for that. But as general practice, I think our utilities do a great job in the distribution redundancy. They have the distribution automation technology to make the power to critical areas very reliable. But for sure, the underserved communities don't have that. To me, that'd be a great solution if we can concentrate, particularly in Puerto Rico, is a great solution to establish these microgrids for these underserved communities or in rural communities in the U.S. Where you kind of have just the last line of distribution and there's not much automation there to ensure reliability. I think a microgrid serving those communities would be a great solution.
Amazing. And I know the clean energy industry is changing all the time, but in your professional opinion, is there any one particular renewable energy source like nuclear, wind, or solar that you see becoming much more dominant in the next few years?
Well, I don't know about much more dominant, but to me as a protection control engineer, nuclear engineer to me is the best option for green energy, right? Because it's green. I know the waste is a different issue, but hopefully there'll be some technology that can recycle that one day. But it's the easiest for the power system as well because it's not an inverter-based resource. It provides good inertia for the power grid, which is what we need because the more inverter-based resources we have with solar, wind, and battery, the more difficult it'll be for the PNC engineer to protect the system because now the system dynamics are changing and how we normally protect the grid. But with nuclear industry, we know exactly what we need to do. So to me, I would prefer more nuclear energy in the U.S. I know things were slowed down, but I understand there was recently a new nuclear power plant put in service not too long ago. So the more nuclear energy we have, the easier it is for the protection control engineer to protect the power system, and we can leave a lot of the inverter-based resources as just backup systems, microgrids for underserved communities, and it would just make my life easier. But again, that's just my personal opinion. But again, as far as the new technology, whatever becomes prevalent, we got to figure out a way to protect it. That's just the way we do. So we got to just figure things out, and as things develop, we will come up with some solutions. But as far as the easiest solution to come up with will be if we have more nuclear energy, we don't have to change much in what we do. But if we have a lot more solar and wind and battery, then yeah, life is going to change a little bit in how we do.
So I'll definitely keep an eye out on nuclear becoming much bigger in the future. And then another question I had is there any lesson you learned the hard way earlier in your career that impacts how you lead engineering teams today?
Lead engineering teams. That's interesting. What did I learn? Well, I've been very fortunate that I think part of it is I was working, I would say, for around 15 years or 12 years before I became a director and leading a team. So I think a lot of that work experience made my life a lot easier. I have a lot of lessons learned as I developed from a junior engineer to a senior engineer. But for sure, once I became a director, again, that's why I'm really cautious for anybody taking this position of a director role in protection control without really going through the experience that's needed because there's a lot of lessons learned that you need to experience before you get to that leadership position and that where your decisions matter. But sure, there's a lot of lessons that I have from a junior year to a senior engineer. But as once I became a director, I had that good foundation, so I really didn't have any type of regrets on any decisions I made, any hires I made. I've been very fortunate, and part of that luck I had was really making my life easier by having that foundation built over several years of experience.
Okay, got it. So you would say it's almost better to have a really wide breadth of experience underneath your belt before you make that so that you're the most prepared you can be instead of climbing up the ranks quickly.
Yeah, exactly. Again, like I said, I'd be very wary of somebody who takes that position rapidly. I'd be kind of cautious working with that person and the decisions they make because, again, our decisions are very critical, and it can literally black out your whatever area responsibility you have.
Yeah, that makes complete sense. So this last question is for all the people studying engineering right now or wondering if what the future, especially in renewable energy, will hold in the future. So in your opinion, what are the core engineering skills that you think will be the most in demand in like 5 to 10 years from now?
Well, that's the thing. I hope people in the universities aren't kind of just geared to the sexy stuff, working for Google's and Facebook and all that. We need solid fundamental electrical engineers, that really the fundamentals haven't changed in 100 years, so we need that, and so that's not going to change. So even when we go into renewables, the foundation is still the same. Ohm's law hasn't changed. That's, if we're running power through power lines and generating power, whether it's through an inverter-based process with renewable energy or through circulating a generator, the foundation hasn't changed, and we need electrical engineers to kind of be not thrown off with the sexy, learn the fundamentals, and if you want some sexiness attached to it, again, the communication area, the digitation area of automation, you can jump into that when you're ready. But again, I would say, I know it's going to be difficult, but I would want engineers and universities to understand that there's a lot of opportunity for somebody who's just looking into the very general electrical engineering study area on power systems. That hasn't changed since in over 100 years since they started writing books on generating power, from Tesla through Tom Edison to now. The fundamentals really haven't changed much. We need to make sure we keep that attractive. Fortunately, a lot of universities are getting rid of their power program because there's not enough interest in it. So that's a challenge for us. And that's going to continue to be a challenge. So again, when I was in my role before as director, where I had very hands-on opportunity to work with these students, I would bring them in as interns and kind of explain to them, this is what we do, this is what you need to keep studying in school, and this is how we apply what once you graduate, this is how we apply all your knowledge that you're gaining into protecting this power grid, how critical it is, how important it is. So it's really kind of like a passion plea for that we need to do with the students to get them to share your passion, and that it's very important to protect this power system, and there's room within this niche area to get into more fancier stuff, so to speak. There is room for that. It's not just Ohm's law. So I kind of do that at the lowest level with the engineering students, and just kind of work up a passion with them that they can share with you. One example I have that I always remember to this day was that I had an intern a long time ago, and he, right from the beginning, he told me from the start that he'll be graduating soon, but he really doesn't have an interest in this area, right? But he wanted to just learn because he wants to kind of use his electrical engineering degree, and I think Goldman Sachs, because they were hiring electrical engineers there, but that was his career path. He was going to go into that area of Goldman Sachs in the energy area. So he wanted to kind of learn as much as he could. He was a very bright kid, so I hired him anyways, even though he was very upfront. Actually, I liked that he was upfront with me. But what I remember is, after that experience, is that he told me, he goes, Alex, I really shared your passion that you shared with me, and the importance of the power grid, what we do, and you made my decision a lot tougher than before. So he goes, so he has something to think about. Of course, the dollar signs from Goldman Sachs, I'm sure took him away. So but still, I appreciated his feedback that I gave him something to think about. Because it isn't just something that's boring to do. It could be exciting, and that's what I try to portray to the intern specifically, that this is an exciting field, and we can compete in that passion level with other industries, and that's what I try to do. And I've been very successful with my interns. Again, I hired like around 7 of them over the course of my career. I hired one back now who's one of my leaders in automation and L&D. So I'm very proud of my track record with that, and I like to. The VP capacity is a little more difficult. I think that level of interaction you need is more for the manager, director level, to kind of share that with their new staff. But definitely in the VP role, I'm establishing the culture for that. So I'm proud of that, and I'm looking for, we just completed 5 years at LND, and I'm looking for an exciting next 5 years ahead.
Amazing. And how have, this is a personal question, but how have you relayed that passion for the industry that's spanned so long? Is it the industry itself always changing that keeps your interest alive, or is just a personal interest in the fundamentals of
No,
power
no, no.
systems?
It is. And that's the thing. I think these last 10 years, you could see the industry changing. Microgrids, more solar facilities, battery storage. So there is a lot of change coming, and we need to understand how that impacts our industry. Automation, as far as, like, again, instead of having these cables going from the transformers and breakers through the trenches into the control room, now it's all going to be fiber in the future, and how we need to change to accommodate that. So there's a lot of exciting areas that are happening that keeps my interest peaked. And again, I'm using whenever the opportunity comes, I'm using that new paradigm shift in how we do things to kind of get that excitement flowing for the new engineer, to tell them, look, things are changing. We need you to really get into this new area, understand this area better than the past, than what we did in the past. It's just a lot of just a very growing area right now in our field, involving new technologies that we need to try to get excited about. It's not just the same old thing that we've been doing for the last 50 years, 100 years. Things are changing now, and we need to adapt to that. We need to be excited about that, and then we need the engineers to study that and implement the new projects.
Awesome. I don't know an engineer more passionate about their work than you. So I'm super thankful for our conversation today. Thank you, everyone, for watching. You can catch my next guest in our podcast studio next week. And thank you again, Alex, so much for this conversation. It was amazing to hear all of your expertise, because it translates not only to engineering, but also to other just life lessons.
Thank you. Appreciate it, Nicole. Take care. Bye.